Okay, hey everyone. This is consensus layer call 111. I'll drop the agenda in the chat. It's PM issue 809. Danny can't make it, so I'll be moderating. And yeah, we can go ahead and get started. So first up, well, yeah, I think Mrs. Call will be Deneb, and then we'll touch on some more research, forward-looking issues. So to get started with Deneb, I think essentially we just want to understand what things are finally going into the spec release soon. So I guess we'll just go through the agenda. There's this issue for EIP 6988. I think Mikhail's been driving this. Let's see. Yeah.
Okay, so about 6988. The problem, so this EIP is about preventing that a slashed value is elected as a proposer, which is basically prevents us from having a lot of empty slots in case of mass slashing. And one of the problems that we have encountered during working on this EIP was that basically this EIP breaks the invariant of a proposer shuffling for an epoch, so it can change throughout the epoch, that's apparently a problem for other clients and for probably some other tooling and some other dependencies. So I've made a PR, which suggests the change proposed by Depline. It basically stores the proposer shuffling in state. The footprint is not that big, and it seems like pretty not that big in terms of engineering complexity to keep it stored in this state. So there is the update proposer shuffling, which basically accepts the state and computes the shuffling for the next epoch, and then we read the proposer indices from this vector. That's the change, and yeah, it's called every epoch processing. This function is called every epoch processing. What's not that nice about the introducing of this function is that if we are bootstrapping from Genesis, for instance, we have to call this function before our state becomes usable and before we are going to process any further slots and propose any blocks. Otherwise, it will just not have the proper shuffling in it. But I don't think it's a big issue. So, and the main question here is whether, considering this additional complexity, whether we want to include its change into Deneb. So, I don't know if anyone took a look at this PR. It would be great. Yeah, if we can discuss it now, so let's do it now, or I would keep it for a couple of days more to take a look into this PR and make a final decision on that EIP, whether it goes in Deneb or not.
So we do have a precedent of having some initialization function for the Genesis state. So yeah, I agree with you. I don't think that's a big problem. It says in the description, it only increases the extra state that we have to track by 256 bytes. So not too wild there. I know there's been some back and forth on this, trying to achieve the aim of the slashing invariant. So yeah, it's good to see this here. Personally, it feels a little bit late to me to add something that is kind of this big, because it is kind of like a change to the mental model of the protocol in the process. I don't know if anyone else has taken a look.
Yeah,
I'll take that. Yeah. I'll take that as a no.
Yeah.
So maybe we have the PR open, and for another few days, and I don't know if anyone feel strongly they should voice support or not support, and we'll go from there. Um, I do. I would imagine it's a bit too late to like decide this on the next CL call, but if that's the next time we get to discuss it, that might be the next time.
Yeah, probably we can briefly mention it on the next EL call if it makes sense. I don't know.
So I think here it would make sense to do a study like we did for removing the self-destruct to understand the implications of breaking the dependent root, which may not be that bad, but I think that's the main question we have to answer here. But definitely it feels tight for the NEP.
Yeah, so definitely if we want to explore breaking this dependent root thing, yeah, I would say that this is too late for the NEP as well. So
Wait, sorry, could you explain a bit what you mean by breaking the dependent root?
So this doesn't show up in the spec, but in the Beacon APIs, all the duties include a dependent root. And the idea is if the dependent root of that specific epoch is not changing because there is a reorg deeper than a number of slots, you are good and the duties should be the same. So I know a few clients, at least I think Lodestar and Lighthouse rely on that. We can get around that and just poll, but it will be good because that's exposed. Who else may be using that dependent root? Because we don't know.
Right, but so I thought partly why we have the EIP for this is to basically maintain its invariant that the shufflings wouldn't change. So it seems then that you'd still have that guarantee for the dependent root, right?
Well, my point is, if no one is using the dependent root, maybe we can just break it.
Oh, you just mean like get rid of it entirely? Yeah. Well, but okay, sure. But my point then is that it sounds like this change doesn't have any bearing on that, or am I not following?
So the EIP 6988 is a reaction to the simpler one that just adds an extra condition on the compute proposer. If we don't mind breaking the invariant, that's a much simpler change.
I see. Okay. So you're saying we could not do this, just make, the few lines change in the other PR and then lose this guarantee. Okay.
Yeah.
Yeah. When I was talking about changing the mental model, I think like having shufflings be, because we're talking about that they would change possibly every slot, right? So that to me seems even more chaotic than what we have today. So I think we should not go in that direction.
I know. Maybe this invariant also used by some other tooling. I don't know. And yeah, it can have some implications. But as for me, not having proposer shuffling stored in the state is a more clear solution. And like breaking the invariant if it is possible.
Another point is if you have to process alt blocks, you need to retrieve the shuffling. So yeah, having to process the block up to that specific slot, that's the cost. But I don't know. I will look into it.
You would have a state anyway, so it's not gonna be a problem.
Okay, so I think we should stay focused on essentially what's going to go into like the final TM Deneb release. And so it sounds like there's still a few design questions we have, some more sort of research we want to do around this particular feature, which suggests to me that we table it for now. Does that sound good?
Makes sense to me.
Okay. Next up on the agenda, there is another issue, this one for extending the engine API for Cancun. I think also Mikhail opened this one. And yeah, anything Mikhail we should know? I think I went the other day and added stuff for 4788, which we'll get to later in the call. and generally it looks good when I looked at it.
No, it's just basically so the spec consists of the Blob extension spec that everyone is familiar with, and also with the parent beacon block root, which is for the other EIP. And the other and last one change that is in this PR in the proposed Cancun specification. For now, it's not probably the last one, which will go into Cancun, is the deprecation of exchange transition configuration. I would just like to briefly go through it. So I think that the spec, first of all, I think that the spec is just not enough. I mean, in terms of tooling to deprecate this gracefully. So basically, it's the spec says that first, execution layer clients must not surface any error messages to the user if this method is not called. If we remove this requirement, I mean, like if we remove this error message, then we can break the dependency between CL and EL. So we remove this on the EL side, and then consensus layer clients can remove this method entirely. So actually, how I see the procedure of removal of this thing is that EL clients remove it right away as soon as possible. Then I mean, like remove the error message, not the methods. Methods should still exist because otherwise, consensus layer clients will surface error because of this method will be responded. So EL client remove the error message. We wait for Cancun, or we wait for every EL client to remove this message, and then consensus layer clients also releases their software without this method being called. And then after Cancun, everyone can just remove it at any point in time. So we will use Cancun as the point of coordination for software upgrade. This is the way of how to do it gracefully. So maybe we can just cut the cord and remove it right away. But then users will see some UX issues by potentially seeing error messages if one client stops supporting it. The other one will complain. So there are two potential ways to do this. I would prefer the first one, which is the graceful one, but maybe there are some other opinions on that.
Yeah, I mean, this graceful approach sounds better. And was that what you have in this PR or something else?
No, it's not described in the PR because this PR is into the spec, and that's why I say that spec is not here. So probably we should just raise this on the EL call and say and ask EL clients, to start removing this error message if they're okay with that. How does it sound?
Yeah, it sounds good to me. I got a +1 in the chat. So yeah, let's make a note to bring this up on the call next week. But otherwise, yeah, sounds good. I know this is something we've been wanting to do for a while, so it makes sense to go ahead and do it.
Great.
Okay, that was pretty straightforward. Okay, so there's a list of EIPs here that we essentially, that are on the the slate for going into Deneb. And let's see, we'll just take them in turn. So the first one is 7044. This refers to essentially changing how we process voluntary exits so that they once made are sort of valid forever. And this was essentially UX improvement because before they expired, and that was not so nice for people, especially in like custodial staking services. Yeah, so it looks like it's been merged into the specs already. And I think it's on here just to call it out. I don't think we really need to rehash it, but I guess it's worth calling out. The next one is 7045. So this one wants to change how we process attestations. And I know that this was around the confirmation rule that some of the fork twist people have been working on. Does anyone here want to give an overview of this? The PR itself basically just says that you have, I believe, the current and also previous epoch to include an attestation on chain, whereas before it was just one epoch's worth of slots. So there's basically this like slots per epoch rolling window, and now it's basically extending back out to sort of rounding down, so to speak, to both epochs, if that makes sense. So I don't know if there are any of the confirmation rule people on the call.
I can try to give an overview on that. It's not only about the confirmation rule, it's also about some other properties in the protocol that we want to maintain under some edge cases. So essentially this PR removes the constraint and gives us the guarantee that attestations that has been produced in the previous epoch will be includable until the end of the current epoch, which is important for the confirmation rule and for some other things that, as I already mentioned. This PR also fixes the incentives part because previously there was the same constraint on the number of slots equal to number of slots in the epoch for the target. As far as I remember, to give the reward for that. So now, proposer will be rewarded for attestation if it even comes from the beginning of the previous epoch, while the epoch has been proposed in the end of the current epoch. So yeah, this part is also fixed. And yeah, I would be pretty much in favor of this EIP this change to be in Deneb, as I think it is straightforward. There is also the other, the P2P part as well. So attestations will be propagated. So the propagation also changed the from the slots equal to the number of slots in the epoch to the previous epoch and the current epoch. All attestations produced in these two are free to be propagated.
Okay, thanks for the overview. Yeah, I mean, I don't really see anything blocking inclusion. So has anyone looked at this in terms of implementation? That'd probably be the only reason we wouldn't move ahead with it if there was some issue. So has anyone looked at implementing this? I'll assume no, if no one speaks up. Okay.
I have a quick question. Does this affect the aggregation subscription in P2P at all? Like which subnet you're supposed to be subscribed to for how long?
I don't
think so. Yeah, I think this is mainly a state transition change.
No, it's a peer-to-peer change as well, and it extends the time that somebody is allowed to send attestations on a particular subnet in peer-to-peer.
Right, but I don't think it changes anything about the aggregation structure.
And that's actually a good question. And the question is that in the current, like before this change, how does the aggregation works in terms of subscription? Whether aggregators stay for a longer time to expect some attestations from the past or not? Because the spec does not seem to say anything about this edge case. I mean, like even with the 32 slots as it is today.
Yeah, Yeah, I think that might be a gap actually. I think we kind of unsubscribe early.
Yeah.
And then the wrong aggregators will be listening to these attestations and they won't aggregate them anyway, so they'll be lost anyway. So I think that's merits at least thinking about.
Yeah, so I mean, like, it does not break that much, this change in terms of aggregation. And I think that there is a probabilistic, this is a probabilistic function. I mean, like, whether there is the right aggregator. So there is still a probability that somebody subscribed to the right subnet. I mean, like, the current subnet can aggregate those, or not. Maybe I'm wrong.
Well, that's the thing that nowadays we will only be subscribing to one aggregate subnet per beacon node and not per validator anymore. And yeah, to be honest, I don't know. I'm raising the question because I have no idea, but it feels like the kind of thing that would, in practice, possibly break this or not break it. It would just render it pointless to be propagating these attestations unless the aggregation pipeline is in tune with this change.
Yeah. So again, it doesn't seem to break anything, but yeah, it's probably the problem that we're discussing now already exists in some, for some all data stations.
Okay, well, so it sounds like we should do a little digging to look into this a bit further. And I suppose we'll discuss this on the next call. I don't think, even if we needed to change the subscription logic, that it would, make this twice as complex or anything. So I would lean towards considering it included. But yeah, definitely something we should take a look at. Okay, so we'll make a note about that. The next one up for discussion is 4788. So I opened a PR for this. Basically, there was like a feature for this, and now it's been in this PR migrated into Deneb formally. There was some feedback from some of you, so thank you for that on the PR. And yeah, this one's pretty straightforward change. We've been discussing this for a while. I think it's pretty much ready to go. There was some feedback here that I can get to, but it won't be super substantial in terms of the spec or implementation. So yeah, I suppose any final thoughts? Otherwise, we'll get this ready and merge it for the Deneb release. I guess it is worth calling out that there was also an engine API change for this in the PR that we discussed earlier from Mikhail.
One thing that I commented out in the PR and that from at the first glance can look a bit odd is that we are duplicating the parent beacon block root on the CL side. So the other way around would be not introducing this into the execution payload on CL side because we have the parent root in the outer structure, in the beacon block structure, and then just CL passes this data into EL, and but EL includes this parent beacon block root into the execution payload, into the actually execution block. But yeah, there was a comment about it and a bit of a discussion, and yeah, I think that having this block root inside of execution payload on the CL side might make sense really from the live client perspective, and probably in some other places it could be useful. So I think it's fine to keep it there, considering that the data complexity isn't really little here. So I'm just emphasizing that because probably somebody else may take a look at that and have a similar thoughts on that.
Right. Yeah. Thanks for bringing that up. So, you could say very strictly that we're like duplicating some data in the block with this extra parent root. And while that's true, the reason it's there is because we essentially want to have this sort of symmetry almost that like whatever we have in the execution payload in the block is what is passed to the EL, and the EL needs this there definitely. So I think it's easier to reason about if we just put it there. As Mikhail pointed out, we could save 32 bytes, but yeah. I don't know if anyone here has a strong opinion either way, and perhaps if you do, you can take it to the PR. Unless you want to talk about it now. Vegeta seems okay in the chat. Thank you. Okay, so those are the PRs here on the agenda. I think the intention is to essentially get them merged into a Deneb release in like the next week or two. And, that would sort of be our final Deneb spec from the CL side. So very exciting to see. And yeah, everyone here, please take a look at everything we've discussed. If there's any final comments, especially beyond what we've discussed on the call so far, let them be known. So with that being said, the next item here is discussing the Blob count. Perhaps this was mainly just a note to call this out that, I think as specs, the EIP says that we essentially have a target of 2 blobs and a max of up to 4. There's been some conversation between different, researchers and devs about bumping that up to say target 3 blobs, max of 6 blobs. And yeah, I think the call out here is just to say that people on this call and others are looking at all the data that we can and thinking about, potential ramifications. Please just keep doing that and, join the conversation to the extent that you're able to do so. And there's a note here, we're trying to make an informed mainnet decision in the next 2 weeks. So yeah, if you have thoughts or feelings about this, you should bring them up soon. I would imagine this will be a topic on the next execution call, but yeah, this is just a reminder that it's happening. At least it's a topic to happen, a discussion point that it may happen. So don't let it fall off your plate, so to speak.
Yeah, and I also wanted to mention for those who weren't on the Monday call that I did more tests at 768 kilobytes. I'm going to share the dashboards in the chat for anyone who's interested in looking at these. As a summary, we didn't see any problematic behavior, any instabilities. We did have some problems with our own node syncing, as far as I know. So the blocks we created, some of them, while we hit the average, were more like 1.5 megabytes and 0 megabytes alternating, which is actually a stronger stress test. But yeah, that was our endpoints. That was a problem there.
Okay, great. And yeah, thanks, Tancraft, for leading the charge on those experiments. It seems like from what we've seen, there isn't any immediate issue with the bigger blob size. So that's a strong argument to make them bigger. Okay, great. There's some data in the chat. Ansgar is asking, how late into the process could we make this decision? Yeah, I mean, I would say the sooner the better. Like, I don't think we want to be like 2 weeks out from the fork and being like, oh, let's change this. Just because it'll ripple into, I think, a bunch of things.
I'll mention one thing which is only weakly related, but it kind of came out of looking at graphs around this, and what's been happening over the past 6 months is that we've gone from practically no reorgs at all to, a few per hour, and we can kind of we haven't there's no great answer to why this is happening. There's a couple of theories. It looks a little bit like it's growing with the number of validators. It definitely became worse after the complexity increase in Capella.
Well, what about the late block reorgs? Wouldn't that be a strong reason why we're seeing this? Because before that, even if you get your block in at as late as 11 seconds, you're probably still going to be on the chain. Whereas now, we reorg those blocks, so maybe it's not that surprising that this has gone up, as 2 clients have introduced that.
Yeah, it's possible, let's say, but if you look at the graph, it's kind of growing. So that could be explained by, more people starting to use newer versions of the clients, but it kind of looks very similar to the validator set growing. I don't want to draw any conclusions here, really. I'm just highlighting it that, when looking at block experiments, this is an interesting thing that has changed over the past few months. And it definitely became worse with Capella. On the spot where we switched to Capella, it's markedly higher on average. And why am I mentioning it right now? Because, we're packing more and more stuff into the first 4 seconds before we're supposed to send an attestation. And my gut feeling is that it might actually be an excellent time to rebalance the timing of sending the attestation and the aggregate. And I just wanted to sort of feel out the call whether anybody's strongly opposed to say, I'm just going to pull some numbers out of my nose here, but let's send the block at 6 seconds let's send the attestation at 6 seconds and send the aggregate appropriately in the middle between that and the next block instead of at 4 seconds. Has anybody explored this and found strong reasons not to do it? Or to do it? I'd be kind of curious because that would certainly help reorgs.
So I'm strongly in favor of this, and I also have the same feeling that this is exactly one of our big problems. We put more and more in the first third of the slot. I think the interesting question would be if people have data on when attestations are arriving in the second, third, and when aggregations are arriving. Yeah, if anyone has that data, that would be very interesting.
Well, we have histograms that tell us when all the attestations come.
Can you share that?
Yeah, I can share it in the consensus dev channel later. The general trend is that, so there are 2 things. In the spec, there is a rule that allows us to send attestations as soon as we've observed the block. Clients are generally not doing this. There's a large concentration of attestations coming in shortly after the 4-second mark. And then it's spread out, but it's fairly, there's a fairly large number of attestations coming in the second after the 4-second mark. So like, as a client dev, if we're pushing the timing back, I would still look into sending, like I would strongly suggest that people implement this feature where we send the attestation a little bit earlier to spread out the traffic. That would help. And I am going to post the exact numbers in the consensus dev channel, but like just gut feeling based, they're pretty good.
Sorry, what do you mean it's pretty good? Just the ones that you gave as actual numbers?
No, as in we're supposed to send the attestation at the 4-second mark, and like by 5 seconds, most of them, most of the ones that we're going to be sent have been sent and received.
Right. Okay. Right.
But again, like this is just me looking at the graph. I'm going to pull it out in a slightly different format to give better numbers.
Sure. Yeah. I mean, data would be helpful. I mean, I also agree. I think this is something worth strong investigation. And I don't know, my concern with, say, deploying this in Deneb is just delaying the fork. This is like a somewhat involved change. That being said, I do think it's like pretty important. So yeah, I mean, it sounds like we should probably spend some resources looking into this ASAP. I don't know if anyone has any thoughts on Deneb and its relation to this change, but it sounds like we probably just want some more data first.
I just wanted to bring up.
Yeah, go ahead, Mike.
Sure, yeah. Just from the relay perspective, some of the issues around relay stability were around that 4-second deadline, and in particular, getting all the relay checks done in time to hit that 4-second deadline. Like if a validator sends a signed header to the relay at t equals 2, then the relay really only has 2 seconds to get the block published in time. So yeah, I think with bigger blocks, that timeline is going to get even tighter for relays. So 6 seconds might help in terms of stability there too. So just thought that was worth bringing up.
For relays, how much of that is like trying to, post the block as late as possible to make more profit versus starting the work on time?
Well, the relay can't start the work until the validator sends the signed header, right? So I guess the validator could play like some timing games. There's a paper from Casper and the rig group about this. Let me get the link for it. It's called Time is Money. I think the takeaway is generally validators aren't playing these timing games. Yeah, I'll post a link in the chat. But the relay still has like some amount of latency that it has to do. Like, for example, simulating the block takes like on the order of like 200 to 300 milliseconds. And then like receiving all the bytes might take like another 200 milliseconds. So like the latency starts to add up quickly, especially if someone calls get payload later in the block. But yeah, like the relay can do stuff like, oh, we'll reject any get header requests past 3 seconds. But if they have a valid header that they sign, the relay is kind of like obliged to try and get the block published, even if the signed header isn't received until like t equals 3.5 or something like that,
Cool. Thanks for the paper.
I think Terrence is
Terrence.
Yeah, I just want to call out that Prism also has the releases coming either today or early on Monday that we do find like an issue where that if today there's a late block and then for the subsequent slot after the late block, that Prism will delay, have some additional latency on block production. And therefore, it may cause issues with the relayer, and that's why if you're a Prism validator, you may see more reorg or not reorg, or your proposed block will have a higher chance of getting reorg, but the fix is coming. So hopefully that should improve things a little bit from the Prism side.
Okay, that's exciting. Yeah, so zooming out a bit, like I think this is actually really important that we look into changing these sub-seconds, or sorry, these sub-slot second timings. So yeah, let's keep this thread going, and we'll see. Again, I won't speak to when exactly it's included, but I do think it's very important for us to dig in here. Yeah, POTUS? POTUS, you have your hand up? We can't hear you. You're muted if you're speaking. Can't unmute. I'm sorry. Maybe try to get it working and just speak up when you can figure that out. Yeah, I'm not sure. There's some messages in the chat, but I'm not sure what. Oh, I can. I don't know if I can. Maybe Tim, do you know if you have the ability to unmute people?
Let me check. I cannot.
I'm getting that you are the only one. I don't
Wow.
know what that means.
I mean, why couldn't he unmute? People have been talking.
Yeah, but I think Danny's the host technically. He's just not here.
Wow, Danny just shadow banned POTUS. Oh, see if login fixes it.
Yeah.
We need
We'll
censorship
get
resistant
him.
Zoom. Yeah.
Wait. Okay, he's back.
Very incredibly
Good now. Yeah, I don't know. I can chat with you. I'm not sure who the actual host is, so yeah. Okay, sorry. If you want to send a message in the chat, we can try to go about it that way. But otherwise, I will keep moving things along.
Oh, wait, I can probably be unmuted now.
Yeah, we can hear you.
Oh, good. So I just want to mention this thing on the sub-second, that it's not so triggered and it's not so clear that you can actually take out time from the first part of a slot, because aggregation becomes a problem and becomes an actual problem. We have a very large validator set that is getting larger, and aggregating is taking over 2 seconds on a normal computer, especially if you're subscribed to all subnets. The highest, I've been monitoring this because we changed in Prism the way we are aggregating unaggregated attestations. And on a normal nuke like mine, it would take up to 4 seconds to aggregate all unaggregated attestations if you are subscribed to all subnets. So that means that you cannot really realistically be a good aggregator if you are hosting more than 32 keys on a nuke. So what happens is that very large validators can run on very faster software, hardware. But I think for small home stakers, you are not going to get good aggregation if you reduce the middle part of the slot. So that leaves us to like shifting everyone and taking only seconds from the last part of the slot. And the last part of the slot, I think it is safer to take some time out of it. But the problem is now with the reorg feature that we place a bet before the end of the slot on whether we are going to reorg or not. And I'm afraid that we're going to see a lot of split views if we make this last part very smaller. So I think that it's going to take a long time to actually get these numbers correct and getting good experimentation that actually vouches to how long we can increase the first part.
So what I don't understand there is, why is the relevant number all subnets? Why isn't it
because if you, so the amount of attestations that you need to aggregate is going to depend on how many subnets you're subscribed to.
Sure.
And if you run more than 30 validators, you are going to be subscribed anyways to all subnets. So So if you're running on a home computer, you can't really realistically run more than two or three.
But you wouldn't be an aggregator on all of those subnets, though.
Well, but you are an aggregator quite often, and you get all this. I mean, you are going to get all of these many more attestations and aggregated attestations that you are going to need to aggregate. So by subscribing to all subnets, you're going to be getting a lot or more of unaggregated attestations.
Right, but you cannot do all that work in parallel, right? Like presumably, if you are running tens or hundreds of validators, you don't just have one CPU to run this.
Yeah, the bottleneck is even we are parallelizing it, and the bottleneck is in the BLST library, and it doesn't matter. Like I see Terence asking whether or not clients are aggregating all at once or as they come. I benchmark this, and it doesn't matter. It doesn't make much difference. Lighthouse aggregates as they come, and Prism just aggregates them all at prescribed times, because the number of additions that you make is exactly the same. It doesn't really change anything. Sure. So I truly don't think that we can really subtract time from the middle part of the slot. We can measure it, and we can try to benchmark it, but I would clearly see a degradation if we subtract parts from the middle part of the slot. And I think measuring the split views that will come from subtracting part from this the last part of the slot is a pain. So I think that we should keep our minds open that if we are forced to increase the first 4 seconds, then we may need to increase the slot size.
I didn't understand why you can't parallelize it. Sorry, that doesn't make sense.
No, we can parallelize it. We are parallelizing. And anyways, we're getting we are getting 4 seconds marks. So the typical aggregation for my computer is about 200 milliseconds. But then from time to time, when there's a missed block, for example, and you need to aggregate more, then you get up to 2 seconds. And I'm subscribed to only and I'm running only 3 validators.
Why do you need to aggregate more when there's a missed slot?
Well, because you get a lot of attestations that weren't included before. That if there's a missed slot, you have the aggregate the attestations from the previous slot. Then you need to aggregate with the attestations from this slot to include more attestations. And my computer takes up to 2 seconds.
That I don't understand, because the previous ones you could already have done in the previous slot.
No, but you still need to aggregate with the current one. So you run. There's always late attestations as well.
Sure, but these you can just add, right? You've already aggregated the one.
Well,
now there comes 10 more. That's very cheap.
The algorithm to add is not so simple. It's simple to add when you only have 1 bit, but then you need to start aggregating aggregates, and it's not trivial.
No, you don't. I don't understand.
Yes, you do.
Okay, so I have
several max coverage algorithms.
I had like 200 aggregated signatures. Now I received 10 more that were late. So
but then the problem is that you're receiving 10 more that have like 2 of them are with intersection with the 100 that you had before, and you cannot. You had like a group of like 7 or 10 of these that have different intersections.
Okay, why do you have to aggregate the aggregates? I didn't know where to.
Because you want to have a better block.
Yeah. Okay.
Compared to Nimbus, at least, that sounds a bit more. Your numbers seem on the high end of things.
Yeah, so I'm giving you the worst cases. So my computer takes very little on the. So the biggest chunk is in aggregating the 1-bit ones, because we take them all at 8 seconds, and we aggregate them all at 10. And I'm sorry, we take them all at 4 seconds, and we aggregate them all at 8. And that one takes, on my 3 validators, is taking about like 25 milliseconds normally, but it gets to 2 seconds on bad occasions.
So I'm looking at some numbers here, actually. And specifically, I'm looking at the delay from the start of the slot when attestations and aggregates arrive. And this was basically the number that was asked for before. And just eyeballing it, like it's in the 97% range that both attestations and aggregates are in 2 seconds after when they're.
Well, but this is a different issue, Jessica. So I'm talking about different things. So in order for us to submit the aggregate at 8 seconds, what we're doing is start aggregating before so that the aggregate is already ready at 8 seconds. So at 8 seconds is our deadline to submit the aggregate. So what we're doing now is before 8 seconds, and this is adjustable by the user, we aggregate them all. And you need that before to have enough time so that by 8 seconds, you can actually send an aggregate. Because at 8 seconds, we're going to send whatever the node has. Because that's the deadline. So our aggregate is always going to be early.
I still feel like you're misrepresenting the issue, because if like nodes with few validators can manage in that time, then I feel like that's fine. Like then that's great, because those are just going to get their aggregations in, and we don't need the others. We don't need everyone to aggregate. We just need someone to aggregate, right? And so if people who run more validators actually need larger machines to run them, then that's not the end of the world, in my opinion.
Well, I do think that this is centralizing force. If we're like going to have like people that are be able to be home stakers can only stake like 1 or 2 validators. Even larger ones. In our clusters, we're seeing 4 seconds.
You were talking about not like you were talking about someone who subscribes to all validators.
I typically, to be conservative, that's correct. But this is the way that we need to, when we submit our clients with default values, we are typically looking at the worst situation, which is a validator that runs at least 30 keys. And there's many of these. And those are going to be subscribed to all subnets. And this is what needs to be our default. So our timing is going to be this, regardless of whether you're a home staker or not. And
okay,
I think
so I just disagree there. I think it's okay to require someone who is running 30 validators, which is like a few million in capital. I think they can afford a machine with a few more CPUs to make this fast enough.
Something to note here, though, is that aggregation is not incentivized, and so we rely on aggregation, but we don't actually incentivize it. The only implicit incentive is that you aggregate your own view.
I mean, there's another point, which is that when you're running 30 validators, you're not aggregating 30 subnets. You're aggregating much fewer. So there's 16 aggregators for every subnet. So your chance of
we're really talking about a node that's running 1,000 validators or something that would actually need to aggregate all of these.
Yeah, my point is that like with 16, like the number is fixed, the number of aggregators per subnet.
And there's the issue that the blocks are full. If you have like many more aggregates that are worse aggregates, like what a validator with only 2 subnets would have, then you're going to fill the blocks with less attestations.
Why would a node with 2 subnets have worse aggregates?
Because they see less attestations. Nodes that subscribe to less subnets, they get less peers.
The aggregations are per subnet.
Yeah, but smaller nodes see many less peers and many less unaggregated attestations than larger nodes that are getting much more peers.
Is that true?
So my node is a much worse aggregator than the node in our Prism like Kubernetes.
I don't understand. Why would, if I'm subscribed to subnet 1, why would make subscribing to subnet 2 as well make me see more attestations on subnet 1?
No, it's also dependent on the number of peers that you have. If you're a home staker like myself on a bandwidth of a home, that I'm restricting my number of peers to be, I don't remember if it was 30 or 50 now by default, then I see many, many less attestations than someone running with 200 peers on a cluster. And we do want to aggregate those.
That's not how the protocol works. So
yeah, that's not how it should
be. The number of peers is completely irrelevant. The only thing that's relevant is the gossip submesh, and that one is capped at, let's say, 8, 12, depending on if you look at average or max. So you can be subscribed to 8 peers and see the exact same traffic that if you're subscribed to 200 peers. It doesn't really matter.
Right, but
and
you
your
need to
block,
have,
your aggregate, when you're creating a block is created from listening to the aggregate channel, not from listening to the attestation channel typically. So the aggregators are doing that work for you basically, and there's 16 of them, right? So
no, but I'm talking about the aggregating the 1-bit attestations, which is when you are an aggregator, not when you're aggregating aggregates. The largest chunk for us is aggregating 1-bit attestations.
Yeah, and the risk of you being one of those guys is pretty small. That's the 16 aggregators that exist per subnet, and you're never subscribed to all the subnets. And again, this is not a function of how many peers you're connected to. That is completely irrelevant. So I think this deserves some more investigation, and I think we should take it offline, and we can go through the flow. But like, it certainly merits investigation, like in-depth investigation of all these issues if we're going to change these timings. And
I'll post
maybe you're right.
in the channels these benchmarks that we have, because we changed these algorithms because of these numbers that we were seeing both in my clusters and home computers, and we were seeing like very large times for aggregations. And
Yeah,
I have
and I mean,
the
like I
percentiles
say,
and everything. I'll post this I'll post the PR as well.
Yeah. I'm just saying that like your peer count, not relevant. That's not how the protocol works. But changing the timings, the other thing I wanted to say actually was that we don't have to put all the time from the, the point where we do the attestation or the point that we do the aggregate. We can play around with that a little bit. Like it doesn't have to be evenly divided. Or now it's evenly divided, and we want to divide it in a different way. But like, it doesn't have to be, 6,
I mean,
9,
it would even
12,
be
or whatever.
plausible to make this flexible, right? To not have a 100% clear division between attestations and aggregation.
Yeah, flexible. I don't know, because that feels like something that somebody could exploit. But like, it could be 2 and 6, or it could be 3 and 3, and whatever, right?
Right. So
I mean,
there's a couple
even
different things.
Even a 1 second increase on the first third, I think would be huge, because in my observations, there are already under normal networking conditions, slots like 3.5 seconds in, like it's not rare to see that. So like if you add 1 more second, that's gonna have a huge benefit to the network already.
Yeah, I think we can all agree that it would make sense to have more breathing room on the front end. And so the question now is just, what are those numbers? What should they actually be? There's a lot of data people have been referencing. We should, I think, moving this to the consensus dev or some async channel is a great idea. Obviously, there's like, this is important and we should keep looking into it. But yeah, we need a lot more investigation before we can just say, oh, let's make this 6 seconds. Let's make this 2 seconds, or however it ends up. Yeah, so let's keep the conversation going, but we'll take it offline from here. So next up, we do have an agenda item to discuss this proposal. Mike, do you want to talk about the max effective balance change?
Yeah, sure. And actually this like kind of flows really nicely from the previous discussion, because the goal of the proposal, I'll link it in the chat, is to reduce the validator set, which hopefully would help with aggregations, kind of not only reducing the validator set as currently, but also slowing down the rate of growth for the new incoming validators. So I'll just give kind of a high level overview of the proposal. We have a few docs that I'll link that kind of outline the pros and cons, and then maybe we can just open up to discussion as far as some of the design decisions go. So yeah, the kind of high TLDR of the proposal is increasing the max effective balance. So this doesn't change the 32 ETH minimum balance to become a validator, but it allows validators to go above that. We've kind of proposed 2048 ETH as a potential upper bound. We don't want to make it infinity, as far as how big a validator can get, but yeah, going up to 2048 we think could be like a reasonable choice. Some of the benefits we outline from the roadmap perspective, we talk about how kind of slowing the growth of the validator set will be important for single slot finality. Daplion brought up the point that and potentially being blocked on the current validator set size, though that is like a little more of a under debate thing. We also talk about the benefits for the current consensus and P2P layers. So that's kind of what we were just discussing as far as aggregation is taking a really long time. There's a post from Aditya on unnecessary stress on the P2P network. I'll link that here. So he wrote that before I published before we published the modest proposal. But yeah, just kind of talking about some of the numbers of on the P2P layer of how many messages are being passed around and all these, you know, the kind of unnecessary bloat from all of the validators. And then we also talk about some of the benefits for the validators. From the solo staker perspective, it gives this kind of like auto compounding benefit, which people seem really interested in. The kind of key takeaway here is that with the current 32 ETH max, the sweep just takes all your rewards and withdraws them. So any solo staker just like would have to redeploy that capital somewhere else to earn any yield on it, versus if we increase the max effective balance, they immediately start like compounding that ETH. So they're earning rewards on more than just the 32 ETH that they kind of initially deployed. We also talk about the potential benefit for larger node operators who wouldn't have to run as many validators. This is kind of like, you know, a big part of the consolidation would depend on the larger validators actually doing the consolidation. There's some risk associated with it because the slashing conditions would result in potentially like higher slashing if they accidentally double a test or they double propose. So there's some risk associated with it. But in general, you know, for large validators, like Coinbase operates something like 70,000 validators, that 32 ETH cap kind of artificially inflates that number for them. And they've, you know, various staking operators have expressed interest in reducing the number of validators that they run, or consolidating the validators into higher stake, but fewer of them. So yeah, I guess that's kind of the high level overview. A few of the big questions, I think, are the design trade-off of the UX versus the complexity of the spec change. So in the proposal, we link to kind of a minimal view spec PR. Let me get the link for that. And it's super tiny. It's 58 lines added, 21 lines removed. So, you know, this shows kind of, the goal here was to show how small the spec change could be, but this has some, I guess, some UX inefficiencies in terms of if someone wants to get the auto compounding, you know, effect, they have to actually withdraw and deploy with a new withdrawal credential with the 0x02 prefix instead of the 0x01 prefix. There's also this idea that, like, yeah, I guess staking pools wouldn't be able to migrate or to consolidate without pulling their validators out and redeploying them with like a 2048 validator. So they'd have to, like, to deploy one 2048 validator, they'd have to exit 64 32 ETH validators and then deploy a single 2048 one. So, you know, I think it's worth discussing a bigger potential change to the spec that makes the UX better and more desirable for people. And then I guess the other big question that's come up, and Donkrat has mentioned this a number of times, is how do we actually get the consolidation to happen? Like, if we make the change, it's only worthwhile if it actually results in a meaningful difference in the validator set size. And, you know, if the UX is so bad and there's kind of no incentive for them to do it, the big stakers might not do it. You know, there might be some social capital that they gain by doing something that, like, quote unquote, is healthy for the Ethereum network and improves the overall P2P layer, but yeah, it's not totally clear that they would take advantage of the consolidation and make it worthwhile. So I guess those are the big questions in my mind. Happy to open up the discussion here, and, you know, also take questions in the Discord channel later if that's useful. But that's kind of the high level.
Thanks. I have a question. Just on your last point there, is the auto compounding not enough of an incentive to sort of migrate to this regime?
Well, so for big stakers, they can kind of take advantage of compounding by they have the automatic withdrawal sweep, right? And then they can just deploy. So for Coinbase, they're running like 60,000 nodes. That gives them enough to deploy like 9 new validators every day just through the withdrawal sweep. So they don't have to really, the auto compounding doesn't benefit them as much as it benefits the little guys. There could be a case to be made that like because the withdrawal sweep takes a long time, like it's 40 days or whatever, that capital is like effectively dead while it's waiting to get out, and so the auto compounding might help them. But yeah, I think other than that, it's not obvious that it's strictly financially better for them to consolidate. Right. Oh yeah, sorry, the activation churn. Yeah, that's the. Thanks, POTUS. That's the 40-day thing that I was meaning to reference.
Yeah, this especially since for solo stakers or small stakers, like one of the bigger benefits was auto compounding. Yeah, I'm with you on like improvements to user experience make it easier for solo stakers, and at least as currently proposed, and this was brought up, but the max effective balance being 2048 is so high. A small staker would almost never experience a withdrawal. Would have to like manually withdraw the whole thing at this point to have a withdrawal. So I definitely do think that UX is improved or needs to be improved in order for like small stakers to take advantage of this. And then another point, I noticed in like deposit processing or apply deposit, like basically people can top up their, if they opt into being a compounding validator, let's say, they can top up their validator with a deposit, and there is like a limit that you can only top it up by 32 ETH, but it seems to be a limit per deposit. And so it seems like they could, I mean, they don't have to really wait the activation queue, they just wait the 16 to 24 hour deposit queue.
Yeah, so this was actually something we tried to cover in the spec, because you're right, if they are able to kind of get around the activation queue, then all of the kind of churn invariants are broken. The way we got around that is just to say, like, if you top up past 32 ETH, that's just like, you can't top up past 32 ETH basically. So yeah, that's kind of like a brute force way of doing it, but yeah, this did come up and it should be covered in the spec.
Isn't that a limit per deposit? Like, you could submit a deposit for 32 ETH, wait for that to process, and then submit another deposit for 32 ETH?
So basically how it works is if we see that the deposit changes the effective balance to be greater than 32 ETH, then the like effective balance of that validator, then we just say, okay, the effective balance is only 32 ETH. So even if the deposit is processed like that.
So how do you implement this thing? You're going to have a validator. You need to keep track of how much part of this balance in this validator was added in this way or was added correctly. This seems like, are you sure about this?
No, it's just a mechanism to stop them from topping up past 32 ETH. You know, we don't care how
do we keep track of this? So how is this mechanism? You don't allow the balance.
So the logic is, if this public is known and the effective balance is already at 32, we ignore the value deposited, so it's effectively burned.
Right.
Oh, so you're killing. Oh, so you're declaring that deposit to be an invalid deposit.
Yeah.
That sounds like, I mean, the contract is already deployed. That sounds like something that is going to lead to a lot of people being burned.
That's kind of true. Yeah.
Yeah, we talked about this. You know, I think, why would someone top up past 32 ETH? Like, people can burn ETH in a lot of ways. Why would they top up past 32 ETH if we tell them explicitly that that ETH is going to be burned? Like, I agree that it would be something we'd have to call out, but I also don't think that that would be a normal pattern. Would
at the very least, you'd have to, like, in the tooling, or like in the front ends that deal with topping up a balance, you know, tell them that it's going to burn it.
For sure. Yeah.
Because a lot of people aren't going to know this. Like, a lot of people didn't know that there's a LIFO queue for the BLS activation change. Like, people just don't know these things about the protocol.
Yeah. I mean, we could also maybe think about ways that the spec, like, we tried to make the spec PR super minimal, and maybe there's a way that we can make deposits part of the, like, churn limit and say, okay, this is what we have the invariant of, like, 1/2 to the, it's like 1/65,000 per epoch can't change or whatever. So just make that.
So, I mean, this sounds extremely drastic. Like, I mean, I think this is no go. And to me, this has actually happened a lot of time that people accidentally topped up above 32 ETH. So, like, I mean, that I think there's no way we're gonna do that. It's so drastic for a small mistake. But I also don't understand why. Why can you not? Why would you want to stop people from topping up above 32 ETH?
You're skipping the activation queue.
Yeah, the problem is if you get a lot of deposits like this, then you get a big change in the validator set quickly. But I think we can just churn this and that's it.
That, or like, especially something that would help.
Right, then deposits just needs, like, the activation queue just needs to be replaced by deposit queue.
Right, and I think we can do this at the same time that we get rid of all of this ETH1 voting, because anyways we're thinking on churning those. So we can just mix these two things at the same time.
True. And in terms of user experience, I mean, I know this is historically a precedent and might add a lot of complexity, but a complete other route is it possible to add a beacon transaction to combine validators?
So I think the proposal right now is trying to keep things as simple as possible, and adding new types of operations is definitely be more complexity.
Right.
Yeah, I think that's kind of the trade-off we keep circling around here, is like spec change complexity versus UX. But, you know, I think it's worth kind of exploring many different avenues and seeing what makes the most sense.
But Mike, I think if everyone more or less agreed about, like, getting rid of ETH1 voting, and there's already a spec towards that. So as long as we move towards putting the churn on the deposit queue instead of the activation queue, I think we can just mix these two PRs into one.
Yeah, that's a good idea.
Yeah, that's helpful. I haven't been kind of keeping up with the ETH1 voting thing, so I'll have to do a little research there, but that sounds promising to me.
I mean, the latest spec doesn't have a queue, but it can be brought back.
But that was just a matter of terminology, right? Because you still have the churn. So the issue of the queue being on the state or not in the state, I think, is minor here.
And the other, is it also, like, pretty heavily planned or leaned into that we're going to enable execution layer with initiated withdrawals?
Yeah, so I was talking to Danny about this yesterday. I think it seems like yes, that will happen. I'm still not totally clear on the relationship between that and this, though.
Oh, it's just that if we also combine that with this, it would drastically improve UX.
Yeah. How do the execution layer withdrawals impact the churn? Maybe that's a question for offline, but
It's not the churn. It's just the fact that if you're a small staker, you basically never withdraw. And if you have one validator, you have to generate 2,048 ETH off of that one, even if
Right.
it's compounding. It'll take. So you need another way of initiating withdrawal.
You're right, but I was just asking, if you do an execution layer triggered withdrawal, like, do they have to go through the withdrawal queue too? That seems okay.
They would have to.
Yeah.
I think the point is that
Yeah, the proposal is for exits, and it would just move into the exit queue like it does today.
Okay.
But the point here is, if we can do partial withdrawals triggered from execution, then we could get rid of partial withdrawals, automatic partial withdrawals, and
You're saying you would do that to add this back into the proposal now that Mike's talking about?
Well, I was actually talking about partial withdrawals.
yeah. So the point is, like, today, if you're a solo staker, you have one validator, you need to at least capture some value to pay for expenses and what's or not. If we disable partial withdrawals, such that you have automatic compounding with the feature that Mike is presenting, there has to be some way for you to extract a value, fractional value of your validator without having to exit the full thing.
Right.
So execution layer initiated partial withdrawals, not full exits, basically.
Right. Although we would presumably need both.
Right.
I mean, that would be cool. Then we could get rid of needing an extra address, right? We could just switch all validators to this functionality, and everyone just withdraws whenever they want.
Right.
So that seems a lot cleaner than the current proposal.
One problem I see with this is that you need to bound the amount that you can actually withdraw on a partial withdrawal. Otherwise, you're gonna get a large change in effective balance in one slot, which might be a problem.
Right.
But wouldn't the partial withdrawal have to go? So the proposal is written to rate limit the activation and the withdrawal queue based on stake rather than number of validators. So if the execution layer partial withdrawal goes through the normal withdrawal queue, then that rate limiting should be fine, right? Like, we just have to make sure that the rate limiting is correct. That's the issue.
Yeah, suppose no, yeah, never mind. Yeah, but it ends up like, as currently written, the queue is, there is no limit for partial withdrawals, only full withdrawals, because that actually affects the validator set. But when you actually have
so the proposal is only to trigger exits, not to trigger withdrawals.
Right, but if we do enable partial withdrawals this way, like, you don't, now you can withdraw even more than 32 ETH and still not technically exit your validator. So you withdraw a validator's worth without going to the exit queue. So yeah.
Yeah, sounds like some more details to work out, but this is potentially promising. I guess the one thing about this is it would change the default behavior. So like, yeah, part of our design goal for the first spec was like, if people don't want to change anything, then we wanted to leave that there. So that's why we left the 0x01 credential alone. But if we change everyone like to compounding with these execution layer triggered partial withdrawals, then a lot of like workflows would have to be updated. I don't know if that's like a big enough reason to not do it, but it's a consideration.
Okay, well, thanks for bringing this up, Mike, and hopefully that was helpful feedback. Thanks everyone for the conversation. Is there anywhere, Mike, you'd want to drive further feedback? Like, I guess just to the ETH research post?
Yeah, ETH research post, or I think Danny suggested the Discord, the POS consensus channel could be a good place. So yeah, I think I should be pretty easy to get in touch with, but would be happy to hear more feedback. So thanks everyone.
Okay, great. Are there any closing or final comments for this call? Otherwise, we'll go ahead and wrap up.
I wanted to bring up an update on the testnet call we had just before this.
Yeah, please.
Yeah, so we had the first Holesky testnet call about an hour ago. And we're going to have the next one again on June 29th with a couple of asks. I can link the summary over here. But one of the big questions that was still open is the current idea is to start with about 1.5 million validators so that we have significantly more than mainnet and we don't have to rush to immediately make deposits to keep ahead. We're just not sure if all clients think that they'd be ready for such a big validator set at Genesis or such a big Genesis state. So just looking to hear some thoughts on that.
Will we ever reach that in mainnet? What percentage of total ETH supply stake will that represent?
I mean, we're at 600,000 now with a queue of about 100,000. So we're already at 700,000 in a couple of months. So we double what we have right now. We're also open to starting with a smaller number like 1 million, but that won't give us as big a difference.
So has anyone on this call like tried a Genesis state that big? I would say if we can get away with 1.5 million, may as well.
But I mean, 1.5 million is 40 million ETH staked. So 30% of total supply. If we do that in mainnet, that would be pretty crazy.
Would it?
I
don't know. I think if you talk to some of these liquid staking people, like they want all of the ETH stakes. So
all
I don't
ETH
think the numbers are completely
stake in the
unreasonable.
Beacon chain and no one can do anything.
I think when we started Prata, if someone had said 15% of all ETH was going to be staked, we would also thought it was crazy, but we're already here.
Yeah, I'm not opposed. Like seeing the difficulties we had in Prata, I will rather start with a big one so we can optimize the clients and get done with it.
Okay,
yeah, I also support the 1.5 million side.
I have a suggestion as well too. I'm not sure how hard is it to do, but one of the things that we're seeing on mainnet is that we now have some validators that are exited. And even if we start with a large number of deposits, we may increase even the validator slice by just adding validators that are already exited at Genesis. So that we start without the need to have like a large number of validators sending attestations, but the slice itself is still large.
That's a great point.
Yeah, we can also take that into account. Thanks. Yeah, besides that, we're looking for client teams involvement to run at least majority of the validators. There's a Holesky planning doc that's been shared on the chat already that states what the requirements would be, like what you can expect to get away in terms of machines. It is a bit of a investment in terms of money. So we're looking for commitments, like solid commitments from client teams by the 29th. And if not possible, then we're going to look at node operators to help us get to the 1.5 million or 1 million or whatever number we decide on. So please talk to your infrastructure teams and so on and try and get back to us before the next call.
I'm sorry, you said that was the 29th of June?
Yeah,
the next call
is going to be on the 29th of June.
Okay.
Yeah, I think that's it on the Holesky topic. Thanks.
Yeah, thanks for bringing it up. It's very exciting to see progress there. Okay, anything else? Otherwise, we'll wrap up a few minutes early. Okay, I'll call it. Thanks, everyone.
Thanks, Alex.
Bye.
Thanks, everyone. Bye.
Bye.